Hello, everyone. This is James Shore with Let's Code Test-Driven JavaScript. You're watching The Lab, which is where we explore, experiment, and generally mess about. And today in The Lab, we're continuing our series on legacy code. This is the fourth episode in our series, and I think it's going to be the last one. We'll see as it goes. And what we're doing here is we're taking a real production application that somebody else wrote, and we are refactoring it and adding tests. In other words, we're dealing with legacy code. The application we're using is intro.js. It's written by Afshin Marabani, and I apologize if I pronounced that name wrong. And what it does is it provides, well, a guided introduction to a website. It allows you to basically walk through the site. And in this series, what we've been doing is we have been trying to figure out how to get this under test, because although the code is well written and it's well commented and so forth, there are no tests around it. And we are taking the perspective that we want to refactor this code. We're acting as if we wanted to add smooth scrolling to the step changes. Right now, when you click around and you skip between steps, it sort of jumps awkwardly. We are saying, well, what if we were approaching this as if it was a real application? We wanted to add step changes and we wanted to do that safely. How could we get tests around it? And then how could we write that code? Now, in this series, we may not actually make that change, but we are going to get that code under test. As I said, this is the fourth episode in this series. In the first episode, we worked on understanding the code and figuring out our strategy. In our second episode, we got our automation in place and we got our pinning tests in place. In other words, we do have the ability to actually test this code now. And in the third episode, just last month, we started refactoring it. We took the show element function, which is the one that actually handles displaying the tooltips and moving things around, and we factored it out from being a very large function to lots of simpler functions that tell the story of how this works. So show element fires a change event, creates the helper layer and shows the tooltip, or shows it using the existing helper layer, sets the button classes, changes the focus, positions the target element, and scrolls to it. All of this is what we did in the last episode. In this episode, we are going to wrap this up by taking the scroll to target element, the one that's actually responsible for adding smooth scrolling to the step changes, and getting that under test and factored out even further. This has been a pretty long series. It's a lot of work, but I think this demonstrates really well what happens in the real world when you're dealing with legacy code. It is something that we're all going to have to deal with at some point in our careers. Most of us have to do a lot of it. So it's useful information to have, and it's good to see how to do it. And it often seems really intractable, really hard to do until you see it. But if you've been watching this series, you see that it's painful and there's a lot of work to be done, but it is completely doable. It's more about just sticking with it than any particularly hard challenges. So let's get into the last episode of this series. We are going to finally get unit tests around scroll to target element. Thank you for joining me and welcome to the lab. Let's get started. To start off, let's go ahead and run those pinning tests and make sure that everything is still working. And it looks like they are. These pinning tests, once again, what they're doing is they're actually running the application, clicking the bugs, clicking the buttons, maybe the bugs as well, and checking the actual DOM, looking at the entire tree to make sure that that's working. And see the second chapter of this challenge for details on that. It's quite slow and fairly brittle. It's, for example, right now, the test will break if my screen size changes. That could be worked around, but in general, pinning tests like this are not reliable, and I try to take them out. Now, what we're going to need to do here, in order to get scroll to target element under test, first, we're going to have to extract it from this function. Right now, it's an inner function. It's right here. That's embedded inside of show element. We're going to need to get this out into a place where we can call it directly. And I think the way I'm going to do that is by making a CommonJS module that operates on, that has scroll to target element exposed. Then once we have it exposed as a function that we can call from a test, we'll need to get our test set up. I'll get Karma up and running. And then we're going to have to figure out how exactly we want to have this function expose itself and be tested. But first, what we need to do is just get scroll to target element out of show element. We need to make it its own thing. Now, as we're doing this, this is an opportunity for us to think about design. The target element, as far as I can tell from looking at this code, is the thing that is getting tooltipped. So right now, the multi-page header is the target element, and now this div is the target element, and now this one is, and so forth. The question I have, what I'm wondering is, do we want to just pull out scroll to target element as a function and sort of a standalone module, or do we want to be more sophisticated and make, I don't know, a target element class or a target element object that then has methods on it, like target element dot scroll to or something like that, or target element dot position above tooltip? These are questions that we're going to want to keep in mind, but when I'm doing legacy code, I do tend to go fairly slowly and take the obvious steps. And I think in this case, I just want to get it under test before I worry about refactoring too much. So, or before I worry about really improving the design, the refactorings I'm doing now are really more about enabling testing and improving the design as I go, but not worrying too much about what the best design could be. Because once we have good tests in place, we have a lot more freedom and power to refactor. So that is something I think we can wait on. So we just need to get this pulled out. Now, if I just pull this function out of show element entirely and put it down here like that, I don't think that will go well. I suspect that scroll to target element is using variables that aren't present in here. So let's see what happens. I'm expecting this to break our pinning tests. Yeah, and they did. Surprisingly, didn't break them right away. And I wonder why that is. Let's try running this and see what happens. Oh, it didn't scroll. Yeah, it didn't scroll at all. But of course, that scrolling behavior is not under test. And then the next page button didn't work. Interesting. Why didn't the next page button work? Yeah, our scroll to target element behavior is not under test at all because scrolling doesn't affect the DOM, and our pinning tests only look at the DOM. Well, rather than try to address that by improving our pinning tests, I think I'll just continue to test this manually because we're getting pretty close to the point of being able to get this under unit test. And I think we'd spend more time trying to fiddle with our pinning tests than we would just testing it manually. That's interesting though. I had no idea that our pinning tests had that gap in them. And this is, a fairly substantial chunk of code that I could have broken without realizing it. Well, just looking at this, I'm kind of surprised our lint isn't failing. I guess we have our linting sort of turned down right now, and I'm guessing that whatever would detect that target element is not defined is turned off in our linting code. And the reason is when I set up the linting, I set it up to work with all the weirdnesses that were already in intro.js, and I didn't try to fix any of them. Again, because changing existing code can break things. Even simple things like fixing lint errors can break it, even if you don't intend to. Let's see. I'm going to try just passing in these values. We've got a target element that we need. We've got element in viewport. That's a function. I'm pretty sure that we've got it. We've got get win size. Rect is defined here. It looks like all we need is target element. Do we have self in here? Oh yes, we do have self. So let's pass self through as well. So I'm thinking that if we just pass through self and target element, we'll be good. Do we make any changes to target element? No, not directly. No, in fact, it doesn't look like we're changing it at all. Okay, so if we come back up here to scroll to target element and we say self, comma, target element, and we run our tests, will they work? They did work. Do we trust it? Not really. Let's see. Try that. Well, it's now scrolling. Now will it go to the next page? Yes, it did go to the next page. It's interesting that breaking scroll to target element also broke the next page functionality, and I really don't understand why that is. But I'm not going to worry about it right now. When you're dealing with legacy code, as I've said many times now, you got to just take what you can, deal with what you see, and trust that it will continually get better. You can't boil the ocean. You can't solve all problems right away. Well, now that we've got this factored out, now we have something that we can put in another module and actually test with a unit test. Now, before we do that, target element is definitely something that we can set up in a test and then check to see if we scroll to it. Self, on the other hand, self is, oh, this is just about options. Look at that. Self.options scroll to element. I want to say that this variable should really be pulled out. I mean, this right here is a guard clause. But doesn't it make sense that we could just say, back up here and show element, couldn't we say something like this? If self.options scroll to element, then scroll to target element. I mean, that reads really nicely and it really clarifies what's going on here. We should be able to say that. Now the question is there an example that doesn't do scrolling? I don't know. I'm going to look into that real quick. Back in a moment. Okay, I'm back. I didn't find an example that gave us what we're looking for, this scroll to element, but it is pretty easy to just set up that example for ourselves. So I'm going to do that in a moment. But before I do that, I just realized that I didn't check in this change after I extracted the method or the function to the outer level. So I want to go ahead and check that in. As I mentioned in the last episode, it's really good to take small steps and to check in frequently when you're doing this sort of work. All right, so we've extracted scroll to target element from show element, got it out to the top layer. Now what I'd like to do is I'd like to pull this piece out because I really don't think that it's part of what scroll to target element is about. I think that scroll to target element is really about doing this assuming we want to scroll to the target element. So if I take this out here, then that effectively breaks the code. But I don't think that we'll be able to see that it's broken. No, it's still scrolling. What I need to do in order to prove that this has been broken is go back into our index.html and add a set option showing that scroll is false. And if I had had this working properly, then that would prevent it from scrolling. And you can see right there, it's not scrolling anymore. But when I take this out, now I've broken that code. Okay, good. So you can see I'm doing the test-driven development cycle manually. I'm still doing the test and then running a little manual test, then changing the code and then proving that the test passed. We're just doing it manually. So here we'll say if self.option scroll element is true, then we scroll to element, otherwise we don't. So now that should fix the code again. It should no longer scroll. There we go. Perfect. So again, same red green refactor cycle. It's just that because I'm not using automated tests, it's slower. But I got a red bar by demonstrating that the code did scroll when it wasn't supposed to. Then I got a green bar by demonstrating that it didn't scroll when it wasn't supposed to. And now I'll take this back out, put it back the way it was, because I'm pretty happy with that change. I'm going to go ahead and check that in. Okay, so we've moved that scroll to element option up a level. Okay, now we have something that is fairly well defined. It's fairly independent. Let me come down to here. Scroll to target element. There's this if we're not in the viewport, then we do everything. And I think I want to refactor this to be a guard clause where basically I'll say if we're in the viewport, then return. But that's something I think I'll wait to do until we actually have unit tests on this. Looking at this, I do depend on get win size. So if I'm going to move this into its own module, there's going to be some issues about what I call. So any functions that I depend on, like element and viewport and get win size, if I move this into its own module, which is the next step, we've got to pull this code into its own module so we can test it independently. If I do that, I won't have access to these functions anymore. So let's find out if anybody else is using element and viewport. And if not, it can just come along with us. No, nobody else is using element and viewport, just scroll to target element. So let's take this and put it up here. And these two things can come together when we move them into their own module. And that should not have broken anything. Except that I modified a file again, so our approvals have broken. I'll go fix that real quick. Back in a moment. Okay, that is still passing, unsurprisingly. I just moved element and viewport. Now let's look at get win size. Who else is using that? Again, nobody but scroll to target element is using that, so that is really good. That makes our life a lot easier. We'll just take this and move it up next to scroll to target element as well. What's interesting to me is that this comment, I am pretty sure if that's wrong. So I'm going to go ahead and fix that as well. And yeah, get the screen dimensions. So yeah, this is all looking good. Let's test this real quick and do a quick manual test as well. Okay, that all looks good. All right. Now our next trick, it is going to be a bit tricky. We've got to take these three functions, scroll to target element, element and viewport, and get win size, and we need to move them into their own file that we can test independently. Because right now there is absolutely no way for us to run scroll to target element because it is captured inside of this closure. And we could export it. We could do that. We could say exports dot scroll to target element equals scroll to target element. I think that would be pretty hacky, to be honest. That would really pollute our public API. People would wonder, what is the scroll to target element thing? It doesn't seem like a good choice. And sometimes, although sometimes I will do something like that just because that's the only way I can see to go forward. But in this case, what I think I want to do is maybe make a bit of a worse hack. I want to use CommonJS to put scroll to target element and its supporting functions in their own module. And in order to get that to work, and then somehow we've got to combine these back together for actual production use. And I think what I'm going to do is I'm just going to use Browserify to make the CommonJS modules go together. And in the process, I'm going to deliberately break AMD and browser globals. I'm going to set this up so that it only works as a CommonJS module. And that is perhaps not a great idea. And if this was if I was doing real production work, I would try to figure out how to make this work. Another way to do this would be to simply write some concatenation code that rewrapped the result in this universal module definition format. But that's not really our focus here. And in the interest of not spending many more months on this problem, I think I'm just going to have it support only CommonJS. So that's a deliberate breakage I'm going to do. And because it's not really germane, it's not really central to what we're trying to do here, I'm going to go ahead and do that off camera, and I'll be back in a moment and explain what I did. See you soon. Okay, I am back, and I got it working. I got it completely working. I was able to get Browserify to export or to output a UMD module, which means that what I'm creating with Browserify is exactly the same in behavior as what Intro.js had before. Probably. I may have gotten some of the actual options wrong. I haven't tested it thoroughly, but it's good enough for our purposes. And our existing examples still work. So the way this works is I just added a new option to our Jake file. Now it's you can run the Jake file with Jake bundle. and it will run Browserify for us. And of course, when you run the test, it will run that for you as well. That just runs Browserify, the tool for supporting CommonJS or Node style modules on the browser or in the browser. We create it, telling it that we want to work with source/intro.js. That's our new source file. Tell it it's to make a standalone UMD module with intro.js as the export, and then we write it out using this. Now, there are probably more elegant ways of doing this, but this is what I already knew how to do, so I just stuck with that. Now, over here in intro.js, it works exactly the same way, except that I pulled out all the UMD stuff that was already here, and I made it so that the entire export was intro.js rather than saying exports.intro.js equals intro.js. And that may be the part I got a little bit wrong. But it still works with our example, and that's the important thing. We run this, it lints it, fixes up Phantom.js, bundles it, and then runs the test. Everything's working great. So now we have the ability to modularize. And that's really important for us because the next thing we need to do is we need to take our scroll to target element function right here, and we need to move it into its own module and then require it from this module. So let's go ahead and give that a shot. I'm going to make a new file called, for lack of a better term, scroll to target element.js. Now, I don't really like that. But again, we take small steps, or I take small steps when dealing with this. And I should be able to, if I'm understanding this right, I should be able to just say, well, let's see. Now, do we really want to call it scroll to target element? Let's call it scroll for now. I don't know if that's any better. And what I'm going to do is up here at the top, I'm going to say var scroll equals require scroll. And that should work just as well because there's nothing in there. And it does. Now the trick is, can I take our scrolly stuff here and just cut it out of here and put it in here? That is the million-dollar question, isn't it? There, I've just now exported a scroll to target element, and let's call it to target element, because then we can say scroll.toTargetElement. It's cute, right? And now if I run this right now, it should fail because we're not actually using scroll.toTargetElement. And we've got a missing semicolon as usual. Let's try that again. Now this should fail. And it does. And remember, we're not actually testing the scrolling, so it's not failing as soon as I would like, but it does fail eventually, and it fails the same way as it did when we didn't call scroll to target element before. So that's good, I guess. So now we should be able to come up here to where we're using it and say scroll to target element, like that. And this should now work, fingers crossed. Oh, that looks really promising. Okay, let's try running this puppy. If we run it and we click show me how, and look at that, it's working. That's awesome. I love it. So now we actually have scroll to target element extracted out into its own module. And that means, my friends, that means that we can finally test this puppy. That is fantastic. So what I'm going to do now is I'm going to get Karma set up. I'm going to do that off camera. If you're interested in how Karma works, then go ahead and see this episode right here. And when I have Karma running, I will come back and we will get some tests around this. We are almost done. Now, in this episode, I'm not going to put every possible test around this that we could. The goal here was just to see how we could get the legacy code under control and starting to get it unit testing. And now we really do have a unit that we can test, and that is pretty cool. So we are almost done here. All right, I'm going to go do that Karma stuff, and we'll be back in a bit. Okay, I am back and things are going well. I'm very happy to say this. I do have Karma installed now. I've updated my Jake file so that you can launch Karma in the same way we do on the main channel, the live channel, and you can run the unit tests. And the way this works is with the Karma runner that I wrote over on the live channel. So I've also written a scroll test. I've put that in the same directory as the rest of my source code, as I like to do. Some people prefer to put it in a test directory, and you are welcome to do that. And I've got this working. So now by default, when I run Jake, it's actually running the unit test, not the pinning test. And look, it's so much faster. I love it. I love it. Okay, so we've got this working. I can say expect true to equals false, and it will fail. I'm only running this against Firefox right now because I just don't feel like dealing with all the different browsers. The point here is to show you how to get the unit tests going, not to necessarily do everything we possibly could. Once we get to this point, though, it's just like the testing we're doing over in the live channel that you've seen elsewhere on this site. We have the ability to unit test now. So let's put a couple tests in, and that should do it. I think the main thing we need to do here, now we're dealing with scrolling, which may not have been the simplest thing to start with, but let's just start putting some tests on this. Now it says that, basically it says if the element is not in the viewport, then we're going to do stuff. And we'll scroll up if we need to, or we'll scroll down. There's a weird comment thing going on here. Let's try it that way. I hope I've moved those comments in the right positions. We've got our variable set here. I really dislike this style of variable setting, but I'll leave it as it is because this is not my code. And the test, of course, the test will still work because they don't do anything yet. So I'm going to run the pinning tests as well. So now that we've got this unit, and it is quite small and easy to test, I think the way we can test it is let's create an element that's outside of the viewport and then scroll to it and see how that goes. Looking at the code, whether or not it's in the viewport is based on the bounding client rectangle, so basically the bounding box. And I believe that is independent of margin. So what we could do is we could create an element with a big margin to force it to be outside of the viewport and then see that it scrolls into the right spot. Let's go ahead and give that a try. Okay, so what we're going to do here is we're going to write a little test to say that scroll to target element scrolls down to put the element in the viewport. And to make that work, as you've seen in the live channel and in other parts of this site, we're going to create a DOM element and then clean it up. And we'll configure that DOM element to work the way we want it to. Now, I'm going to be a bit quick and dirty on this because, again, the details of this unit test isn't the important thing. The important thing is just how we manage legacy code, and we've mostly done that. So I'm going to go ahead and write this test, and I'll be back in a bit. Okay, I'm back. I've got a simple little test here that creates an element and positions it absolutely. I realized as I started to write this test that would be simpler than dealing with margins or any of that crazy stuff. And then I do style it with a red border and some text just to make it a little easier to do manual testing. I've also set a timeout so you can see it. So right now I've got this position 500 pixels down, and if I bring this up in the browser, you can see there it shows up 500 pixels down. If I change that to 100 pixels, then we'll have to rerun the test first to reload the page. And then you see it's 100 pixels down. So we should be able to position this some ridiculous amount of pixels down, like 10,000, and then make an assertion about, and then scroll to it and make an assertion about whether or not it's actually been scrolled. So that's what I'm going to do next. I'll be back in a moment. Okay, I'm back. Window.pageyOffset will tell us how far we have scrolled. Scroll-Y will also do it, but apparently PageYOffset is more cross-browser compatible. This does not work on IE8, but again, that's not real cross-browser compatibility isn't our purpose in this lab, so I'm not going to worry about it. We should be able to say if the top is at 10,000 and we are supposed to scroll to 30 pixels off of that, then we should expect the window page offset to equal Well, 10,000 minus 30, which is 99970, or 9970. And to make that a little bit more clear, let's say 10,000 minus 30. And let's run that. This should fail. And it does. We got expected 0 to equal 9970. Now, the reason I expect it fails is because we're not running scroll yet. So we should be able to say scroll to target element and put our div there. So let's see what happens. This should now pass. Didn't. But it should have. Target element is undefined. Oh, right. We're supposed to pass through self. But we took that out, actually. So I'm just going to pass through null and the div, and let's see if this works. Still no luck. EL is undefined. Okay, I figured it out. This is a bit tricky. Target element is not the DOM element. So what we need to do here is we actually need to rename this to be DOM element or something like that. Let's start out by just having, right now, let's just pass in what it's looking for, which is element div, but obviously that's not very good form. We're going to want to fix that. But I'm thinking if we do that, we can get this to work. Yes, it is working. It didn't scroll to exactly where I thought it was going to scroll to, but it did work, sort of. There we go. There we go. If we put some bottom padding on it, then we get the answer we expect, which is 10,000 minus 30. Yeah, so the issue was that we is just related to the nitty-gritty of how the page is laying out, and I don't think it's that important, but we do have it working now, or the test working the way we expected, so that's good. Now that we have that working, I'm going to fix this issue here where we're actually not doing what we think we are. And rather than saying scroll to target element, I'm going to say scroll to DOM element. And this, rather than passing in the target element, I'm going to pass in the DOM element. And that means we don't have to do this dot element everywhere. Now, this will still pass our unit tests. Well, it will pass them as soon as I take out that element div. And we can take out this timeout as well. It's not necessary. But it shouldn't pass our pinning test because we haven't fixed the call to use the new format. It's not dereferencing the target element. So I'm expecting that this will blow up on us. And it did, which is actually kind of good. So now what we need to do is here, when we're calling scroll to DOM element, we need to say target element dot element. There we go. And you can see how we're starting to make this code a little bit more generic, improving the design just a little bit. That is the kind of thing that I expect to happen once we've got our test in place. Now this is failing though. And I was expecting it to pass. What did I do? Oh yeah, it's not scrolling anymore. I broke it. Great. Oh, well, I'm editing the wrong file. I'm not editing our source file. Let's try it here. Here we are. So there we go. Another good reason to have these pinning tests. And there we go. So now toTarget element takes a DOM element instead. Now we can go back in here and see what else we want to change. It would make sense if we tested the case of it scrolling up to put the element in the viewport as well. Okay, I'm back. I've set this up with a spacer. We've got a target at the top, spacer down here, and of course the target can be reconfigured. So now I should be able to change the target to, so here I'm changing the target to be at 10,000. Here I'm going to change it to 200, but then I'm going to scroll to 0, 10,000, and I'm going to expect the result to be, oh, where is it? Let's put this at 1,000. I think it's going to scroll up to 800 or something like that. Not entirely sure. But anyway, let's see what happens with this. Now, right now I'm not scrolling back, so it should fail. Oh, it's window.scroll. Yeah, expected 10,000 equal 800. So it is scrolling down to 10,000. Now, when we call scroll.toDOM element, it should scroll back up. And we get 70. Okay, great. Why 70? I don't know. I don't know, but that is the correct answer. And what happens if we put this at 1,000? Then it should be 970? Yeah, 970. So 1,000 minus 30. Interesting. It seems like this is the only one that's getting triggered, and I'm not exactly sure why. If this was a real effort, then I would probably spend more time on it. But as it is, I'm okay just triggering this top one. But this scroll up, scroll down comment, it seems like we're always scrolling up or something. I don't know exactly what's happening here. But that's all right. We got this working. And we shouldn't need this padding bottom anymore. So when we run this, does that still work? No, it changes the answer. Now it expects 9956. Huh. I don't know why. I'm just going to hard code it. So there we go. We have successfully unit tested the scroll to target element function in intro.js. Now, there is clearly a lot more that we could do here. We could test the element as in viewport. We could refactor this function. But I think you see now how we are now back in the land. We have escaped the land of the hideously slow pinning test. And I'm going to make you sit through it at its real speed, not fast forwarded like I have been doing. This is its real speed. The hideously slow and extremely imprecise pinning test, we've gotten out of that land, and now we're in the land of the nice and fast unit test. That runs in just a fraction of a second, and we could write a lot of these, and now we can really get into the details of how toDOM element works and how the scrolling works. And it's just like it is if this wasn't legacy code. So that is our conclusion to the legacy code challenge. We have successfully gotten our legacy code under test to the point where testing it is just like anything else we do with unit tests. And we can do cross-browser testing with Karma. We can have fast tests. We can have detailed tests. There's still, some craziness here, but overall, it's really good stuff. So I'm going to check in these final changes and then be back to wrap up. So let's review what's happened in the last 4 chapters of the Legacy Code Challenge. To start with, remember that we started with intro.js, a big function that does intros. It does all the stuff moving around on the screen. It was well programmed. It's not as huge as some code could be, but it didn't have any tests, and we didn't understand it. So the very first thing we did in episode 1, in part 1 of the series, is we went through and we really spent some time understanding what all the functions were and figuring out our strategy. We decided that we wanted to pretend we were going to focus on smooth scrolling. And you can see how now you could write tests in scroll tests to implement smooth scrolling. We're not going to do that here. We decided that that's what we were going to look at doing. And then we figured out what our strategy was. Our strategy was going to be to put in pinning tests and then to refactor the code so we could test it. And in fact, that's what we did. In part 2, we wrote the pinning test so that we could check that we hadn't broken anything. In part 3, we refactored the code to pull out the various parts of show element and make it easier to understand. And in part 4, we chose just one of those functions to pull out into its own module and make testable. And this really is nice and testable now. Now, this has been a lot of work for just one small function, but the thing is that when you start doing this legacy testing, you're going to have to go all the way from the biggest outside-most piece, as we did, understand it, and then focus in, as we did. Now, in the future, when we come back to making additional changes to show element, we can pick just one of these things pull that out and get unit tests around that and so forth. And the more you do that, the more under control it gets, the easier things get, and you just keep on going. This is the approach I use for testing legacy code. It's not glamorous. It's not dramatic. It's slow, steady work. And it's eminently doable. Anybody can do this. You often hear people talking about how terrible it is to test legacy code. Legacy code is everywhere. It's not that bad. It's just a bit tedious. But once you get it under control, you can make a pretty big difference in a surprisingly short time, because next time we come into show element, we have a much better understanding of what's going on here. And the next time I come into intro.js, I also have a better understanding of how the whole thing works. And that is how it works when you're working with legacy code. It takes some effort to get started, but then once you're in it, it gets easier and easier over time. So take these ideas, apply them to your own code base. It is possible to test legacy code. It takes some time, but it's not that bad. And it doesn't take any particular brilliance or anything like that. It just takes, again, slow, steady work. So that is the end of the Legacy Code Challenge. Thank you very much for watching, and I will see you next time.